Hi, my name is Noah Stransky, and I'm going to talk to you about tidal energy. A little agenda here. We're going to do an introduction and background. We're going to look at the technology feasibility, the sustainability assessment, and we're going to touch on the economics and public policy. A little introduction. Tidal energy is a rising force in the energy field. It has a lot of potential and opportunity for success. Renewable energies are making a huge push right now. We're looking for great alternative energy sources to replace fossil fuels, and we're really realizing the importance of doing this. So there's some really good similar technologies to tidal energy, which include wind turbines and hydropower. These are really leading the way and helping tidal power to come to be. And there are a lot of challenges that come with tidal energy, which include the challenges from the environment. And we'll talk about that more later. There's a huge opportunity for advancement here, and it could really be a big thing in the future. So onto the technology feasibility. There are several methods for collecting tidal energy, and these include tidal turbines, barrages, and lagoons. Tidal turbines are much like wind turbines, except just underwater. Barrages and lagoons are more like dams. So as I spoke about earlier, tidal energy has a lot of benchmarks already set in the renewable energy industry, especially through wind turbines. Wind turbines have benefited the technology in two major ways. First, they broke ground for many of the challenges tidal energy is now facing, including the components of the turbines themselves and converting energy and going into the grid. And then on top of that, the success of wind turbines really proves the feasibility of tidal turbines. It shows that since there's such similar technologies, if one works, hopefully the second one will work just as well. And as you see in the bottom right picture there, tidal energy is very predictable. It's well studied and well known how it's going to react. So that makes it a lot easier than wind turbines themselves. One great thing for tidal energy is the new programs and simulations that are out there. We can predict tide height and mass, the timing that it's going to come through, and we can also map the flow within a tidal turbine farm. So we can put many tidal turbines together and see how they react to each other, and really optimize the efficiency there. So the efficiency of tidal turbines and tidal energy as a whole generally goes around 40% at the most, which is okay. It's not great. And then when you operate in a wind farm, since we've had all these improvements in programs and simulations, we've got up to around 82% efficiency of a single tidal turbine when you're in a farm. There's also a lot of new technologies coming out, one of which is bidirectional blades. This allows for the turbines or the barrages to collect energy when the tide is coming in or when it's coming out, because the blades operate efficiently in both directions. There are a lot of challenges to tidal energy, and this is mostly due to the fact that it is underwater. Installation is very difficult. It's hard to drill and to work in that underwater high energy area. It's hard to gain access to the areas, and there has to be access roads built actually to the facilities near the wind turbines or the tidal turbines themselves. And then because of the environment, again, we end up with a lot of wear and tear, and maintenance is very difficult. Onto the sustainability assessment. There's obviously all the pros that come along with the renewable energy. We're going away from fossil fuels. We're going to something that is more carbon free. There's no harmful byproducts, and it's completely renewable. But then again, on the other side, there are some cons to how it affects the world around us, and it really does not have a great effect on the local area that it's installed in. It'll destroy the seabeds. It could cause changes in water flow, including the way the tides come in and out. or it could affect the oceanic currents, and then water quality in the barrages is affected because the sediments can't flow as they need to. Um, and then on top of that, there's the sustainability of tidal turbines themselves. Is a tidal turbine project really that sustainable because it goes through all of those issues with the rough environment that we talked about earlier? It's going to wear down quite quickly, and like I said, maintenance is difficult. Next, on to the economics. There's a pretty massive upfront cost. It can cost about $150,000 a day for installation, and this mostly comes from drilling. And these projects can last weeks. So it's a really high upfront cost. And once again, maintenance can be very costly. But the demand for this type of project does exist, and where we really do want to move to renewable energies. So everyone is looking towards something like this to take over. The current levelized costs are about 8 to 12 cents per kilowatt, which is not quite as good as most fossil fuels, but it is better than a lot of the other renewable energies. For example, solar is much higher than that. Public policy is heavily involved because we're affecting the environment so much, both in good and bad ways. And they get involved by having requirements on the foundation design, and also there are extensive grid codes. So when we go to connect to the electronic grid, we have to follow a lot of different codes. So in conclusion, tidal energy is a rising and viable renewable energy source. It has a lot of potential for us. New innovations are continuously coming out that improve the feasibility and efficiency. And installation maintenance and sustainability are areas of concern, but once again, these new innovations could really help us out there. I think it's a reasonable project for a large company that has the money to put in up front and is ready to stick with it, and is ready for a big new technology to help with their income. All right, thanks for listening, and have a nice summer.